Hello everyone. And welcome again to the Mathmetecher channel. In today's video, we make an experiment from a bag that contains 4 balls, of which 2 are of red color, and the 2 others are of blue and white color. So we will at first, pick up a ball and keep it out of the bag, then we pick up a second ball. Hence, the result of this experiment is a couple of which the first element would be the first picked ball and the second element is the second picked ball. After this, we link our experiment to a game according to which we will be getting $100 for every picked ball of red color, and $200 if the picked ball is blue, and we lose $200 if a white ball is picked. And we note, capital X, the random variable that associates to each result the won or the lost amount of money. So we're asked, at first, to represent this experiment by its tree diagram. Then, to find out the value of the random variable capital X and to give its law of total probability, and finally, to calculate the expected value of this random variable that we note as E, capital X. So, let's start by tracing the tree diagram of our experiment. For this, we will note as W, the event according to which the picked ball is of white color. And as B, the event according to which we pick a blue ball. After that, as we have 2 red balls, we will note R1, the event of picking one first red ball, and R2, the event of picking the second one. Now, for our first pick of a ball, we may get a white ball, hence the event W, to happen. Or, a blue ball, which mean the happening event is B. Or, the first red ball, hence the event R1, to happen. Or the second red ball, which mean the event R2. Now for our second pick of a ball. Assuming that the first picked ball was of white color, we might be getting the first red ball, hence the event R1, or the second red ball, which mean the event R2, or the blue ball, which mean the event B. Now if we assume that the first picked ball was of blue color, we might be getting for our second pick, either the first red ball, hence the event R1, or the second red ball, which mean the event R2, or a white ball, hence the event W. After that, if we assume that the first picked ball was the first red ball, we might be getting for our second pick, the second red ball, which mean the event R2, or the blue ball, hence the event B. Or a white ball which is noted as the event W. Finally, if we assume that in our first pick we got the second red ball, we might be getting either the first red ball, hence the event R1, or a blue ball, which mean the event B, or the white ball, hence the event W. So according to this tree diagram we drawn, we count the number of all possible outcomes of our experiment, which equals 12. Now let's find out the possible values of our random variable capital X, and its law of total probability. So we will remind that according to the game to which our random variable X is linked, we will be getting $100 for every red ball we pick, and $200 if we pick the blue ball, and we lose $200 if the picked ball is the white one. Now as the result of our first and second pick of balls may be the blue ball and the white ball, so the amount we win and the amount we lose cancel out, and give us the first possible value for capital X which is 0. Or it might be the 2 red balls which give us the second possible value for capital X, which is 200, or it might be the blue ball and one of the 2 red balls, so we get the third value for capital X, which is 300, or if we get the white ball and one of the 2 red balls, so we get the fourth value for capital X, which is minus 100. Now for the first value for capital X, which is 0, that matches to getting a blue ball and white ball, the number of its possible cases is 2, as we may get our blue and white ball either in the first or the second pick. Hence, the probability for capital X equals 0, equals 2 over 12. After this, for the second value for capital X, which is 200, and that matches getting 2 red balls, the number of its cases equals 2, as we may get either the first or the second red ball in our first and second pick. So the probability for capital X, equal 200, equals 2 over 12. Then, for the third value for capital X, which is 300, and that matches getting one of the 2 red ball and the blue ball, the number of its possible cases equals 4, as we might be having the first or the second red ball, with the blue ball, and either in the first or the second pick. So, the probability for capital X equals 300 equals 4 over 12. Finally, for the fourth value for capital X, which is minus 100, and that matches getting one of the two red ball and the white ball, the number of its possible cases equals 4, as we might be having the first or the second red ball, with the white ball, and either in the first or the second pick. Hence, the probability for capital X equal minus 100 equals 4 over 12. So we can resume the law of total probability of our random variable capital X in the appearing table. Now let's calculate the expected value for our random variable capital X. So, as the expected value of a random variable capital X, E capital X, is defined as equal to the sum of the product of each possible value for capital X, xi, and its probability pi, then E capital X, equals 0 times 2 over 12, plus 200 times 2 over 12, plus 300 times 4 over 12, plus minus 100 times 4 over 12, which equals 100. As always, thank you for watching. Consider to subscribe to the channel and activate the notification bell to see more of this content. Like and share the video. And until the next one, have a great time.